Okay, today we're going to talk about S7K.1 Binomial Distribution using Pascal's triangle. So right now, just check your answers on the warm-up. Okay, and you can check your answers on this part of the warm-up. Now, in this lesson with binomial distribution, our focus is going to be entirely on sampling with replacement. What does sampling with replacement mean? It means the denominator is going to stay the same for our probability. So here we had a 2/7 chance of being purple and a 5/7 chance of being green. Sampling without replacement, we have 2/7 chance and 5/7 chance, but then after you've gone this way, you've taken one of the marbles out, and now we only have 6 marbles to choose from. So when the denominator changes like that, that is not binomial distribution, and this type of calculations won't be used in this course. Okay, so if we tossed a coin, you could just say you could either get heads or tails. You got a 50-50 chance, and so we're focusing on the coefficients here. You have one pathway to go heads, one pathway to go tails. Okay. Now, if I'm flipping two coins, you have two possible options. You have heads or tails, and then heads and tails, and heads and tails. So when you look at this, you could either get tails and tails. You could either get 0 heads, or you can get tails and then heads, and heads and then tails. You add those two paths together, and you could get to chance of getting heads twice. You've got the blue heads and heads. Each of these paths is 1/4. 1/2 times 1/2, 1/2 times 1/2, 1/2 times 1/2, 1/2 times 1/2. And there's 2 of these yellow paths. That's why we have the 2 here. Now, if I flip the 3 coins, you may remember the tree that we had, and we end up with, if we've got our tree with, let's see if I can find it. If we've got 3 coins that we're doing, then you end up, each pathway is 1/8. And so getting heads 3 times, we just follow the yellow pathway. Getting heads twice, we've followed the blue pathway, and there's 3 of the blue pathways. To get heads only once, we follow the orange pathways, and to get no heads, we follow the pink pathways. So we look at the number of pathways for each color. Each of these pathways is going to be 1/8. So the yellow is 1/8, the pink is 1/8, the orange it's 1/8 but times 3, and the blue is 1/8 and it's times 3. And so when we denote that on here, we've got 1, 3, 3, 1. So this accounts for the yellow, the blue, the orange, the pink. 1, 3, 3, 1. Okay, so now we could do another prediction of how the next thing would work. And so here we keep the powers here, or the probability was 1/2, then it was 1/4, and then it was 1/8. So what keeps happening is this keeps getting multiplied by 1/2 again. So 1/2 times 1/8, this becomes 1/16. Now, how did we get these orange values here? So what we've noticed is we've got 1 and 1, 1, 2, 1, 1, 3, 3, 1, and we start to see that this starts to look just like Pascal's triangle. And then so how we get the next numbers, which is 1, 4, 6, 4, 1. Now some of you are thinking, well, how, for those who are absent, how did we figure out that it's this pattern? So to get the 4, you can do 1 plus 3 to get 4, 3 plus 3 to get 6, 3 plus 1 to get 4. And we always begin and end with 1. Okay, so the next part is how do we do this if there are 5 coins getting tossed. So I need the next row, which is 1, 5, 10, 10, 5, 1. And those coefficients get put in front of each one. And then instead of 1/16 or 1/8 or 1/4, we multiply the 1/16 times 2, and we have 1/32 times those coefficients. And remember, with probability, add it to 1. 1/2 plus 1/2 equals 1. 1/4 plus 2/4 plus 1/4 all adds up to 1. All of these add up to 1 because you either have, when you're flipping 4 coins, you either have no heads, 1 head, 2 heads, 3 heads, 4 heads. You're not going to get 5 heads if I flip the coin 4 times. Okay. So, when tossing the coin 5 times, what is the probability of getting heads all 5 times? Well, I'm going to use this one here, 1/32. Okay. What is the probability of getting heads twice? So I'm going to use this one here, 10 times over 1/32. And then what is the probability of getting heads at most twice? So the probability of getting heads no times, probability of getting heads once, probability of getting heads twice. And then so we get those 3 probabilities and add them together. Okay. So so each time the probability is 50%. Okay, when we either have heads or tails. So what we're doing is we're doing a discrete random variable, and this happens only with sampling with replacement. So now we're going to make the Pascal's triangle with 6 rows. Okay, to get the next one, 1 plus 5 gives me 6, 5 plus 10 gives me 15, 10 plus 10 gives me 20, and so on. So now we're going to talk about the probability of success or failures. Okay, but before we do that, what happens if we're going to consider A being success and B being failure, and each of these probabilities have to add up to 1, right? So if I'm flipping a coin, this would be 1/2 and this would be 1/2. Okay. We talked about this in class. I'm going to let you hit pause, and we're going to move on to the next part. Okay, so in this example, we're going to be using the Pascal's triangle from the previous part. Now, unlike the coin when we toss that, this we have a 1/4 chance of success, the probability of getting blue is 3/4, and the probability of not getting blue is 1/4. So we think about this as success or failure. So the success is 3/4, failure is 1/4. Okay, these two are the only probabilities of you either get blue or you don't get blue. Okay. So we have this drawing here. So if you get blue 3 times, it's 3/4 times 3/4 times 3/4. Okay. If you get blue twice, you follow one of these pink pathways. Okay. If I want to get blue once, I follow one of these yellow pathways. And if I want to get no blues at all, we're going to follow the green pathway. So, very much like what we did with the Pascal's triangle, we are dealing with tossing 3 coins. So if we're tossing 3 coins, I'm using this row here. This is called row 3. And this would be row 0. Okay. So anyways, the third row, there's 4 terms. 1, 2, 3, 4. Okay. So when I look at this, I'm going to use the values from the row 3, which is 1, 3, 3, 1. So we spin the spinner 3 times. There's 4 possible ways for success. We either get all 3, all 2, 1, or none of them. Okay, and so I've used those coefficients. So now the thing I'm going to do is, okay, success is if I get the blue side. So we're going to have the power of, it's going to be 3/4 cubed, right? Because 3/4 times 3/4 times 3/4. Okay, now if I'm going to get blue twice, I'm going to have 3/4 squared. And so if I've had success 2 times, then I'm going to have failure once. These exponents have to add up to 3, since we've got 3 trials going on. Now if I'm going to get blue only once, I'm going to have 3/4 to the power of 1, and I'm going to have 1/4 squared, because these powers have to add up to the number of trials that we're having. And I could get none of my spins could have blue, and then I would have 1/4 cubed. Okay, so hopefully this explains some of this. You're going to see this sort of notation where it's 3/0, 3/1, 3/2, 3/3. This is a way to figure out what part of the Pascal's triangle we're looking at. So, for example, we're using row 3, and to get 3/0, that is this value right here. Okay, to get the third row 1 success, that's this one here. The third row 2 successes is that one there, and the third row 3 successes gets me this one here. And so we replace those values with that. Okay, let's go on to the next page. Now, before I do, you might see some notation that looks like this. So N refers to the number of trials, P refers to the probability of success. And the other important thing is, as I mentioned before, these powers together are going to add up to the number of trials. And so in this example here, these powers 1 and 2, they add up to, the spinner was spun 3 times. These powers add up to 3. These powers add up to 3. These powers here add up to 3. These powers here add up to 3, because it was spun 3 times. So these powers here are going to add up to what the number of trials, how many times we spin, how many times we do the experiment. This P here value refers to the probability of success. In this example up here, success was 3/4 of the time, and failure is going to be 1/4 of the time. So this here would have been 3/4. This here would have been 1/4. Okay. Okay, write down the first 5 rows of Pascal's triangle. Boom, there we go. Okay, what's the probability of getting hitting the target twice? So we're going to look at this row here, and getting the target twice is, this is getting it none at all, getting it once, hitting it twice. So I'm going to replace this value here with 10. Okay, so we've hit the target twice, so the probability of success is 90%, so I'm going to put 0.1. And so since we want to hit the target exactly and only twice, this power here has to be 2. Okay, so if I'm shooting the arrow 5 times, then, and I've got 2 chances of being successful, that means I have 3 chances of being unsuccessful. So I'm going to have to do 0.1 to the power of 3. And as I mentioned before, both of these powers add up to the number of trials, which is 5, and these two probabilities, the 0.9 and the 0.1, add up to 1. Now this one here, at most 3 times, that means we need the probability of 0, plus the probability of 1, plus the probability of 2, and plus the probability of 3, getting the target 3 times. Okay. You might want to hit pause and think about this. Okay, next question. Which of these probabilities represents binomial distribution? Okay, tossing a coin 100 times is binomial distribution. Tossing 100 coins all at once, that is also binomial distribution. It's the same type of situation as A. You got a box of marbles, you draw one at a time, and then you put the marble back in. That is binomial distribution because the probability doesn't change, just like in our warm-up we talked about. Problem B, without replacement. This is not binomial distribution because the probability changes every time when you remove the marble and don't put it back in. This is not binomial distribution, although because we have so many bolts in here, the answer would be pretty close to that of binomial distribution, but technically it is not binomial distribution because you're pulling the bolts out of the bin. Okay. Question 3. You toss the coin 4 times. What is the probability of getting the following things? So if I'm tossing the coin 4 times, I'm going to use the 4th row of Pascal's triangle, which is 1, 4, 6, 4, 1. Okay, so if we've done this and we're getting heads 4 times, I'm going to use, this is 0 times, 1 time, 2 times, 3 times, 4 times. I'm going to use this value, the 1. And so success is 1/2, and we want success 4 times, so I'm going to have a 4 there. Okay, so, we want to get heads 3 times, so 1, 2, 3. So my leading coefficient is going to be 4, and we want to get success 3 times, so I'm going to have a 3 here. So failure is going to be this to the power of 1. Remember, these two powers have to add up to the number of times we've tossed the coin. And we want to get heads twice, so 0, 1, 2. So we're going to have the leading coefficient of 6. Probability of success twice, we're going to have a 2 here. Probability of failure is 1/2, so we're going to put the 2 there, and these powers add up to the number of times we've tossed the coin. Okay, tossing the coin 5 times, we're going to use this row here. Okay, so we want 4 heads, so we're going to use the blue one there, and success 4 times, failure 1 time. Okay, heads twice, so we're going to use the yellow one. So success is going to be 2, failure is going to be 3 power. Okay. We want to get heads 4 times and then 1 tail. So we're doing just one pathway, and it's going to be like this. Okay. Almost done here. Okay. You've got a box of chocolates containing strawberry creams and almond centers. So the ratio is 2 to 1. So the ratio is 2 to 1, that means I've got a 2/3 chance of being successful and a 1/3 chance of not being successful. So the probability of, and we've got 4 chocolates, so I'm going to use the 4th row. 1, 4, 6, 4, 1. The probability of all of them being strawberry creams. So we're going to be using this coefficient here, the 1, and our probability of success is 2/3, and if we want it to be 4 times, we're going to have it to the power of 4. The probability of getting 2 of each type means we're going to, this is 0, 1, 2, so we're going to be using this coefficient of 6. Success, we're going to have 2/3 squared. So failure, you're going to have 1/3 squared because there's only 4 chocolates to get. Okay. At least 2 strawberry creams. So you're going to have probability of 2, 3, and 4 strawberry creams. So we don't use the probability of 1 strawberry cream or 0 strawberry creams. So I find out each of these here and I add them together. So probability of getting exactly 2 is 24/81. Probability of exactly 3 is 32 out of 81. Probability of exactly 4 is 16 out of 81. Add those all together. Okay, next one. You got a board game that's got a spinner like this, and the ratio of getting red to blue is 3-to-1. Okay, the spinner is spun 6 times. Find the probability that we're going to get blue twice. So if you think of it this way, if you get blue twice, that means we get red 4 times, because we're spinning the spinner 6 times. So it's either red or blue. So if I've got blue twice, that means I'm going to have red 4 times. So if I go to my 6th row for this problem, to get a value of 4, we go 0, 1, 2, 3, 4. So my leading coefficient is going to be 15. And then I've got 3/4 to the power of 4, because we want to get red 4 times, and we want to get blue twice. So I have the probability of failure, and then that's going to be squared, because these two powers, the 4 and the 2, have to add up to the number of times that we've spun, which is 6. Okay. Now, probability of getting at least 3 blue. So at least 3 blue means I'm going to get, if I'm going to get at least 3 blue, that means I'm going to have 0 red, 1 red, 2 red, 3 red, but I'm not going to have any more red than that, because then I wouldn't have at least 3 blue. So I'm taking all of these coefficients, the 1, the 6, the 15, and the 20, and I set this up, and there we go.